All right. Now recap what we learned previous lecture. If we use principle of something of linear impulse and momentum, you write your equation or the force integrate with time equal to the change of momentum. Right? Change of momentum is mv2 minus mv1. All right. So remember to write your equation in all your solution. Okay. So I mark your test one. One of you in your solution, you miss out some of the very fundamental equation. For example, F equal to m. You miss out a lot of marks, and I cannot give you mark because you don't explain what you're doing, right? Okay. By using this one, right? What is on the left is what is before. On the left hand side is you can write what before equal to what after. So you can rearrange momentum before plus sum of force multiplied by time is impulse multiplied by equal to mv squared. Okay, so either you write any form also correct. So let's look at application of this impulse and momentum, right? This is application in civil engineering. So you are doing some piling activities. So your pile is 800 kilogram, driven into the ground using a hammer, 300 kilogram. The hammer fall from rest, so you're given the velocity before at a height of y equal to 0.5 meter. So as you can see on the screen, so you have it. If you see datum again, there are two possibilities. You see datum, you either solving potential energy or you only see two datum in two cases. One is the pulley system. Or potential energy question. Right? So this one, datum, then very high prices need to solve using energy equation. Right. So it's right on the top of the pile, determine the impulse which the pile exerted on the hammer. So the question asks you about pile exerted on hammer and not hammer exerted on pile. It's a different scenario. It's a different scenario between pile exerted on hammer and hammer exerted on pile. It's a different. So this question asks you about the pile, not the hammer. Okay. If the pile is sounded entirely by a loose sand, so that after striking, the hammer does not bound off the pile. Previous tutorial or question, we already know when we have momentum case before and so momentum, if you talk about momentum, normally the question is stick together. We are not interested in the energy or force G. So when together, we call it coupled, join, then your impulse, your internal impulse can be zero. Your impulse, it becomes internal and it becomes zero. When it becomes zero, it becomes conservation of momentum. So MB before equal when it's coupled, right? Oh, sorry, MVR. So this one, momentum before equal to before after. But in this case, we have two bodies. So two bodies, you need to have two momentum equation. So M1 V1 plus M2 V2 equal to M1 V. This is second case. M3 plus M2 V4. 3 and 4 is after. Right? So if we couple like this, if we couple, then you join this one together. M1 plus M2 both move in the same velocity. This one is it bounce off. This one join together. Okay. So so we know that after striking, hammer doesn't rebound off the pile. So when it doesn't rebound off, what does we estimate, or how the movement? The movement will move up or move down when it strike. Go down, because it doesn't rebound off, right? So it be the positive direction is here, go down, right? All right. Now first we draw free body diagram as usual. So when it doesn't bound off, we find the two bodies. The chocolate color is the hammer. The blue color is the pile. So when two things join together, there's two forces there. In this case, I use R as a resultant force. So again, you should able to identify which one is which one by imagining you are that bodies. So if you are the chocolate color bodies, what do you feel? You feel something striking your bodies. So the positive R is for the hammer. Okay, so if you are the blue color, what do you feel if a hammer hit you? You feel some force hit your bodies. So the minus R is the blue color bodies. Okay, so this is important. You'll see this one in your test 2 or final exams. When it asks you like what forces acting on that bodies, you should able to calculate, right? All right. So in here, my velocity is going down, and y is going down. Now in this case, why do I do not use F equal to ma? Because the question asks already give me the impulse. So impulse throughout chapter 1, 2, 3, 4, even 6, 7, 8. If you see it, very high chances it's fall under principle of linear impulse and momentum. So you write this one. So in this equation, you have impulse, you have momentum. Okay, there's only one equation throughout this module that use impulse. We did this one. Okay, so you write linear principle of linear impulse and momentum equal to impulse equal to the change of momentum. So that's why we don't need to use F equal to ma. All right, right. There's no forces from the soil because it's a loose sand. Loose sand will absorb all the force, right? So this is from the civil perspective. Okay. So you imagine how come there's no force here? No force here, it means if you are the blue color object, when you go inside the sand, you don't feel anything because it's loose. If you feel anything poking inside your body, it means there's a force or something pulling your body, then there is a force. So if you are the blue bodies, you go inside sand and the sand is loose, so actually you very easily go inside the ground, so you don't feel anything. Of course, there's a friction there, but in this case, we just ignore the. Okay. Weight of the pile, so we ignore. Okay, so you ignore. Of course, there is a weight there lah. If you want to say that, sir, is there any weight? There is a weight in this case. Right. So in this case, they are impulsive. There's impulsive. So impulsive means no impulse. Again, what is force? Force is force multiplied by time. Okay, so weight multiplied by time. So in this case, the pile doesn't hit anything, right? There's no interaction between the pile and the sand. So there is no impulse here. Yeah. So if this is a hard rock, then yes, but this is a soft sand. So there is no impulse for the pile to go inside the loop sand. Okay. Okay. Uh, so in this case, the conservation of momentum we use, right? The conservation of momentum we use. Why hammer is 0? Because it already stick together with the power. Hammer, when they hit, doesn't rebound off, means they already meet together. It become one body already. It become particles, one particles. Okay, so W becomes 0. Okay, so here, that's why from principal linear impulse momentum equation, we cancel out the impulse component. We arrive at conservation of momentum, where is momentum before equal to momentum after. So as long as there's a mass, there's a velocity, then you have momentum. So here you have two bodies. So you have momentum for A, momentum for B, before equal to momentum after A and B. So in this equation, you have your velocity of A and B. Velocity of A before it strike is rest. So 0. B also 0. So this side is 0. Right? Okay. So from here, what else? Velocity. Okay. How do you find of the okay? So the velocity is the same. So you only have one unknown. Let me see. I'm a 1. Let me try to. Zero. Okay. Right. Because this side is 0, but you have value here, value here. Then you move this one to another side. All right. So move it to another side, then you can take the ratio of the mass, then you get this one. Okay, then you use the principle of impulse of momentum. You look at individual bodies. When you look at individual bodies, right, for the hammer, for example, hammer, then you write for the hammer, free body diagram for the hammer, plus the principle of impulse of momentum. Right? So how do you find a VA? We have V2 here already. Right? So you use conservation of energy to find your VA. Okay? To find your VA. So conservation of energy is energy before equal to energy after. Right? Now, most of the time, if you are given datum, you need to find the pulley problems or potential energy problems. When you need to find potential energy problem, usually you are dealing with energy. There are two types of energy involved. So here is potential energy and kinetic energy. Right? So when we use potential energy, we have kinetics plus potential before equal to kinetic after. So here, if we look at the hammer release from rest. So release from rest, there is no kinetic energy, but there is a kinetic energy after. This one, potential. Again, hammer is above datum. Above datum, potential is positive, right? And when it reach the datum, when it join together, there is no potential. So this equation balance, then you're able to find V1. Yeah, the concept is to use principle of impulse momentum. Here, there's something missing, but you can use the conservation of energy equation to find the missing parameter. Yeah. So you substitute all the value inside there, you can find your V1. Okay. So when you substitute inside there, you can find your impulse. Please move to another side. You can able to find your impulse. Okay. So this is how you calculate lah. Okay. So I've given you a few example of principle of linear impulse and momentum and how we use it. Right. We use bumper car. We use bow, and so on. Next one. Right. So impact, there are two types of impact. So this impact, if you are playing snorkel, then this one is easy for you. So there are two types of impact. One is central impact, one is oblique impact. What I mean by central impact? Central impact means the two ball or two sphere, they meet in a straight line. The line of impact is straight, and the plane of contact is perpendicular to the line of impact. Okay, when two sphere meet together, A and B meet together, they meet each other or they hit each other in a straight line. Okay, then the plane of contact is at the center. Right. But for the oblique, the two sphere meet at the center at a certain angle. Okay, at a certain angle. So A come from the delta with the velocity A at a certain angle. B come from another side, meet with A at a certain angle. In this case, gamma or phi. So when you have a meet face to face in a straight line, they call central impact. If you are in the oblique case, then they meet at a different angle. Okay. Okay. So this one is quite direct. What is difficult part is the solving solution. Central is more simpler compared to oblique. Oblique, this one, if it's central impact, you only have y and x, so you only need to solve x direction solution because only have one direction. But for oblique, for this case, you need to split your vector into x and y. You need to split your direction, your velocity vector into x and y. Then you solve for the impact solution. Okay. Let's look at impact. So we slow down the motion. So before, we now look at central impact where two meet in a straight line. So let's say we have two spheres here, A and B. A move faster than B. So for sure, A will kiss B at a certain time, right? It will chase out the B. So when there's a velocity, there's a momentum, or there's a kinetic energy. In this case, we just drop the energy first. We drop at momentum. We discuss on momentum. So before impact, we have this case, MB A and VB. Okay, and you know that momentum of A is bigger than B because velocity is higher. A, we assume the mass, we assume same. We assume same. So you imagine we're having a snooker game, a snooker ball game. So before impact, so when they meet together, both of them will squeeze each other. We call it deformation impulse. So when they meet together, the shape will deform a little bit. You squeeze, and we assume that this is elastic scenario. Elastic means the energy will bounce back, means it's able to return to its original form. So when A chase out B, they will meet and squeeze each other. So when they squeeze, there's a change of shape. In this case, we call deformation impulse. So if deformation impulse is force multiplied by time, it's just the same. There is an impulse when two items meet together. Okay, so they'll squeeze. Okay, so when there's a deformation, there's an impulse. There's a deformation, then there's an impulse, right? But there's a different direction of impulse. Again, here you need to identify which one is A, which one is B impulse. For example, which A is negative or positive impulse? A is positive or negative impulse? Why positive impulse? If you are A, what do you feel? You feel something from the back, or you feel something from the front? If you are A, you feel something hit you in the face, right? So the force actually coming from your face, right? So if you're A, you're coming from here, but you're actually meeting with B, you feel something bump in your bodies. The force is negative. This is positive direction to the right, but you feel something hit you when you meet with B. So minus F dt belongs to A. Don't confuse with positive. Positive, negative, because you're focusing on the force. So you need to identify what force acting on your bodies. In this case, if you are A, your force go inside your bodies is from the back or from the front. In this case, it's from the front. Because you're moving to the left, to the right. Then you hit with B, you feel something hit your bodies from the front. So the force is actually opposite your direction. So it's minus P. dt. So try to understand this one. Okay. So after this, after the short break, we'll go into rigid body already. Everything very simplified, everything sum into one point or one bodies. So later we look at rigid body, we need to so we will reach a case where they will reach a maximum deformation. And when they reach maximum deformation, both will move in the same speed. They squeeze up to maximum, cannot squeeze anymore. They will move in the same direction. So before impact, deformation impulse means they will squeeze each other, then reach maximum deformation and move together. Okay. So we learned about this one before. This is called coupled behavior, where momentum before equal to momentum after. Okay, so if you want to use conservation of momentum from this before impact to the maximum deformation, you can use MVA plus MVB1 equal to M1 MA plus MB bracket B. If you want to investigate what happened before to the maximum deformation phase. Okay. Again, when we need to use the equation for impulse, we use equation of impulse, this one, linear impulse. We use this one only on individual body investigation. You come to this one, when you look at two body, this one disappeared. Because it can either, if you two bodies, then this one become internal process already. We're not interested in internal process when you look at two bodies. But if we look at individual bodies, then this one impulse come into place. Why? If you look at individual body, you feel something with your dead bodies. Force acting on this if you just body. For example, if you are A force your back, if you're B, you feel something from your back. So the force is positive because you are same direction with your motion. Okay, yeah? So this is the highlight when you need to use or when you can apply MV plus impulse equal to momentum after. Okay, you use this one when you study individuals' bodies. This one for the same bodies. But if you look at two bodies, then this one impulse disappeared. This one, careful. When impulse disappeared, it become conservation of energies, conservation of momentum equation already. Okay. So we continue the motion, maximum deformation. Then there's a restitution impulse. What I mean by restitution? You squeeze already, you start to bounce. You will feel the effect on the A and B. Okay, there's these two impulse. They also, when the one bounce back also, then there is an impulse. So again, if you want to, you join already, then you want to bounce back, you still feel something on your body's one. For example, you're A, you still stick to B, right? If you want to bounce back, you still feel that B is pressing your bodies. I mean, you join already, then you still go together and you want to split already, but you still feel something touching your bodies. So this one, effect A on B, this one effect B on A. So, oops. Okay. Okay. So at this stage, restitution impulse, there are two scenarios. One, either go back to its original shape or permanently deform. Means it will either go back or permanently deform. Like a car crash, it will not go back to original form at the current technologies. There's no self-healing mechanism yet on the current car, so it cannot go back, right? So, but for snooker ball, yes. For snooker game, it will not deform, so it will go back to original shape, right? Okay. So restitution impulse push the particles apart from one another. So this restitution impulse is the one that push the balls parts. So don't confuse with deform impulse. So when you read the question for impact, chapter 4, read carefully what question want you to solve. You want to solve, the question want you to solve deformation impulse or restitution impulse. It's a different cases. restitution, I use R. In practical, your impulse for deformation is higher than restitution. In practical, in practical. So that move in the speed. So you place snooker ball. Normally, the white color ball hit color balls. Before impact, white color will travel faster than the color ball. When two meet together, usually white ball will slow down, and the color ball will move faster. So same with this one. So they have, if you have velocity, then there's a momentum. So MVA, VB2 will be faster than the previous one. Okay, this will be the normal impact, normal scenario. So there are phrases before deformation, then maximum deformation, then go into restitution, then go impact. 5 phrases if you want to separate. So each one will give you different equation based on the analysis. Okay. So if you look at two bodies, we simplified principle of linear impulse momentum. If you look at two bodies, we simplify the equation into conservation by ignoring, or we cancel out the internal impulse happening to between the two bodies. So you can use conservation of momentum to analyze before and after. If you're interested in before and after of two bodies, then you can use conservation of momentum. And if the question asks you what happened to that individual body, then you use impulse inside your calculation. Okay, so that's how you differentiate when you need to use conservation, when you need to use the principle of impulse and momentum. Okay, all right. So if you want to go into individual one, you use the principle of linear impulse and momentum. So this is when you look at two big body or a big perspective before and after, you use conservation of momentum. If you want to calculate what impulse or what forces acting on that particular bodies, you use principle of linear moment and momentum, linear impulse and momentum. So the rest you read from the slides here. Okay, so the rest is just keep these phrases. So this one is for the impact. Impulse, I want to calculate impulse also. It's the same. So this one is restitution phrases for particle A, or for balls or sphere A. So it's from one phrases to another phrases. So this one is from from the maximum deformation until after impact. This one is a restitution impulse, right? So there's a differences between the R and P. R and P. Okay. So just let you see the difference. All right. Now, again, what is important that you understand when you need to use principle of linear impulse and momentum, when you need to use the conservation of momentums. Okay. All right. So I put the two equations together. During deformation phase, you get one impulse. During restitution, you get one equation. Okay. So you take this equation because we are looking at individual bodies or individual particles. So when you take the information of deformation and restitution, you can use one more equation, which is called coefficient of restitution. E is a ratio between restitution and deformation, or after divided by before. You take the impulse, you put the after and before. Every time when you look at ratio, normally one is after, below one is before. Output, input. Output, input is always same in apply to all the efficiency or any coefficient. Always take output divided by input or after divided by before. Okay, in this case, we are looking at coefficient of restitution. We take after, which is restitution divided by deformation impulse. You take this one divided by this one. Okay. Right. So if you take the two equations together, you take this equation divided by this equation, right? This is a restitution impulse, which is this one. So when you move this minus to the right hand side, you move this one to the left hand side, you get MAV minus MAV A2. You pull out the M, you'll get V minus VA2. There's an M in front, but you cancel with the bottom one. Bottom one also same. There's an M below. You just cancel it. You arrive at this equation. Right? Okay. So again, you don't need to memorize this one, but if you see the question mention coefficient of restitution, straight away write this definition. E equal to restitution impulse divided by deformation impulse. Then you write what happened to the deformation formula. Then you rewrite the equation, because here it might not, it depends on cases. So it's good to always know how to derive the equation. Okay. Right. Because some of you, when I change the question, I give you velocity V here. I give you velocity number 3, you are confused. I change the number, I change the location, you are confused. So it's better you memorize or you understand what is coefficient, then you derive equation from one case to another case. Okay. All right. So this is for A. A have one set, B have one set. A have one coefficient, B have one coefficient, because different material. Okay, you do the same. So that's why I ask you not to memorize the equation, but memorize or try to understand what is the definition of coefficient of restitution. Don't go and memorize this one. But if you derive the equation, you'll still arrive at the same for like what you see on the screen here. Okay, so if you do A and B, if you do for A and B, you arrive at E equal to VB minus VA and VA1 minus VB1. Okay, so this is after a long derivation, you arrive at one equation, really this one. Okay, so this one again, you need to do a little bit more exercise, or do the derivation steps. Then you're able to understand this one. Okay, this one apply the positive negative sign, apply only in the case we discuss. What case we discuss? A move faster than B, and it knock together in this case, and into the left, to the right, right? So what happened if the ball from another side? This one doesn't apply. If the ball moves from your right to the left, hit A, will it move faster? This one moves slower. But this one maybe, the direction, if I change the direction of these two ball of velocity, in this case, two move in the same direction. What happens if I change the question to another? If your another ball move another velocity, this one doesn't apply anymore. The positive, negative sign. Okay, so what's important? You understand the definition of coefficient. And then how you get this one is from the principle of linear impulse and momentum for that particular bodies divided by deformation impulse. Then from there you derive the rest of the equation. Okay. The one that you see here only apply when object A move faster than object B. This, the one that you see on the screen here, only apply these cases. If the starting scenario different already, this equation cannot be applied. Yeah, you need to derive from the beginning. Okay. But what is, you can see here is that on the top here, it's actually is a relative velocity after impact, which is B minus A2 after, and relative velocity just before the impact, VA minus VB. Okay, why this one is A1 and B1, and this one is B2 minus A2 is simple. You always take because A is faster than B before, and after impact, B move faster than A after impact. We will get positive value always to get the coefficient. The coefficient always positive. Okay, so in this case is A faster than B before, and B move faster than A after. Okay, so there are two cases. If they are elastic, means the deformation go back to its original shape, and two objects bounce back, then it's a elastic impact. It's like a snooker ball games. Snooker ball games, they are elastic impact. They are perfect elastic. We can say snooker ball, they are almost perfect elastics. Right? Okay. So if the question mentioned they are elastic impact, then your coefficient is 1. If plastic impact means like a car crash, the elastic impact is 0. Okay. Okay. So if the collision join together, coupled stick together, join together, then the plastic impact is 0. So plastic impact 0. How you get 0 value? You divide, which is your infinity? On the top or bottom? So think, what cases give you 0? What give you unsolvable? I'll go and think. Okay. All right. The rest the same, still the same. This one you read lah. This one you read. Okay. So this one is a linear impact. Another one is the oblique impact. So oblique impact with the angle, you derive the same equation, but now with the angle. For example, A before, A after, B before, B after, the impact X and Y. Okay. So in the test 2 or final exam, remember to draw the plane of contact in your free body diagram. Right? Because you need to explain whether this is a central impact or oblique impact. Okay, by diagram. Okay, so we have 4 unknown, but basically you split them into 2 directions, solve the same equation like central impact. Right? So as you can see on the screen here, you split your velocity A1 into x and y. This one split into x and y, like what you see here, plus the impulse. So this is the principle of linear impulse and momentum. Principle of linear impulse and momentum. Momentum before plus impulse equal to momentum after. Again, when you need to use principle of linear impulse and momentum, you study individual particles or individual bodies. Then only you will see impulse. Okay, if you study two body, then most of the time you will ignore this. Okay, yeah. So you just split the direction before to after. Again, this is I want to highlight when you need to use the principle of linear impulse and momentum. Okay, all right. So we start with the discussion example 7. Right, click. Okay, number 7. Airbags A with the mass released from rest with a velocity v 0, position 0, falling to an angle 90 degree, strike 9 kilogram box. If coefficient of restitution between two bags on box is 0.5, determine the velocity of the bags and box after impacts. It's the loss of energy during collision. So there's a line of impact here. So when this one move here, what is the motion of A, linear or collinear? Collinear. So when it's collinear, you can do A and T, a normal and tangent analysis for A, because what is important is before impact and after impact. Right? Again, if you want to look at before and after two bodies, you can use conservation of momentum. But if you want to look at individual bodies, then you can use principle of linear impulse and momentum. Here, the question further asks you loss of energy. So there are two types of energy only in this module, kinetic and potential. So in this case, you need to draw your own datum, either here or here. If you are here, then your potential will become negative when they hit the impact. If your datum is here, you charge up the potential before you hit this one. Okay, so just need to be careful. So in this case, is a central impact scenario because when we hit at the line of impact, both go in the straight line. Okay, okay. Then how we solve? We solve by solving one individual bodies first. We go by drawing datum because it's asked us loss of energy. So we'll have conservation of energy here, which is kinetic plus potential before equal to after. So you draw a datum on the top, W go down, right? So there's your weight mg always pointing down, right? And by now you should already understand what is conservation, what is conservative and non-conservative one. Okay. So conservation of energy, you have two energy only, potential and kinetics. So here, you know that before is 0. Okay. Again, general equation is very important for this module. All right. So you just write what is kinetics, half mv square, what is potential, mgh or wh, before equal to after. So before is 0, start with release from rest, right? You release from rest. So 0, you have potential, and after you don't have potential because, before you don't have potential because you release from datum, but after you have negative potential. Okay. the left side you have 0, right hand side you have value. There's only one unknown, which is your velocity of A. In this case, you need to be careful. Why? Because you are arriving at a quadratic equation with a square. You need to know which one to use. There's a positive value and negative value. Okay. So we are choosing 4 point something for A. Right. So then we look at conservation of momentum. Just after impact, B doesn't move. A coming with the velocity. Okay. So in this case, we can use what we learned in our PowerPoint slides, where A coming very fast, B very, very slow. In this case, B doesn't move. So the whole set of equation we can use. So after the impact of A and B, A slow down, B move faster, then we can use all the equation that we discussed in our class. Right. So VA we already know, VB we already know, so we can use conservation of momentum. Again, why we can use conservation of momentum? Because we are dealing with two bodies and not individual bodies. When you look at individual bodies, then we use principle of linear impulse and momentum. Okay, just before impact, just after impact. So just after impact, VA and VB like this. So after impact, we assume A and B travel to the left, which is move a little bit. Right? We assume. So our positive direction is to the left positive. So momentum, MV before plus MV after. Again, you should be able to understand by now why you can use conservation momentum in this case and not principle of linear impulse and momentum. You should already able to differentiate already. Yeah, because you are looking at two bodies and not individual bodies. If you look at individual, then you need to call out the impulse already. You need to use the full set. You plug in all the numbers. You need to find your VA2 and VB2. You have two unknown here, right? So how do you find the two unknown? You use coefficient of restitution. So because the question give you this one, you sure need to use the definition of restitution. So if you have the scenario where A move faster than B before and A move slower, B move faster, then you can use this definition. This is after divide by before, and we deal with velocity. So velocity after, you always want to make sure it's positive. So you know that VB after is faster than A. Before you want to make sure it's positive value. So VA minus VB. 1, 1, 2, 2. Okay, so this is how you memorize or apply the equation. Right. So you have another equation, solve simultaneous equation. Right, solve simultaneous equation. You're able to find VA and VB. Make sense, huh? Try to understand the way we solve it. Okay. Right, solve to you find your VA and VB. Okay, once you have the velocity, you can find the loss of energy. Okay, the loss of energy, we need to call back principle of work and energy and not conservation of energy. Conservation means no loss of energy. But if the question asks you about loss of energy, you need to call it's a principle of work and energy, right? Which you learned in your coming out in your test one a few days ago. So you need to use principle of work and energy to find. So in this case, we use kinetic energy, right? So we move that around and we put in all the numbers, right? We put in all the numbers. Okay. So after you have kinetic energy, after you have two bodies, so kinetic for A, kinetic for B. Before, you only have one kinetic energy because one body doesn't move. So another side is 0 here. Then you calculate, the unit is joule. Unit is joule. I already marked your task 1. More than 2 students, your answer do not have unit, so you lost a lot of marks there. You get the right answer, but you do not write unit. Sorry to say, you lost a lot of marks. Let's say this is 2 marks. You miss out this one, I give you 1 mark. Okay. Yeah. So this is how I will take that as your homework. Right. Go home and read example number 8. In the same scenario, you only need to split the vector into x and y. I go and read your homework, this one. Okay. It's the same procedure. So what is important I want to show you is that you split all the vector into x and y. Same in this case, when you split x and y, you look at individual bodies, not same like the previous example 7. If you have a oblique, you need to look at individual bodies already, and you solve by using principle of linear impulse and momentum. Or in short, when you see oblique impact, you need straight away use principle of linear impulse and momentum, focus on individual's body, split them into x and y direction. Okay. The rest you read lah. Okay, this is your homework. Okay. Okay, we have a short break. Then we continue with angular momentum. Yeah, maybe 5 minutes break. So continue 9, 10.